So you've seen trinomials and binomials and monomials. These are all called polynomials. Really, that's just a fancy word for an algebraic term, or a set of algebraic terms. Now, if you've forgotten that work, click this link and go check that video. But for now, we'll see how we do some calculations in multiplying and dividing these polynomials. Let's get down into it. Alright, so let's get back into doing some algebraic calculations. Now, let's have a look that when we work with polynomials, what are we going to do when we multiply, and also what we do when we divide. So let us have a look. Now, this might seem very similar to you. This might seem very familiar to you because we have done something very similar. When we have this 2 standing in front of the bracket, we know that this needs to multiply in with everything inside of the bracket. And so let us simplify this first. And so 2 multiplied by 3x squared is 6x squared. And 2 multiplied by positive 6x is positive 12x. And 2 multiplied by negative 1 is negative 2. But hold on, when we get to this next bracket, watch out, because when we have to multiply in, what are we multiplying in? Now remember, if there is no coefficient, we can say that there is a coefficient of 1. And so negative 1 multiplied by 2x is negative 2x. Negative 1 multiplied by negative 4 is positive 4. Please watch out to not just drop the brackets because there is no coefficient. There is always a coefficient of 1. And so let us simplify by adding like terms. We have 6x squared, positive 12x, negative 2x. And so we add or subtract the coefficients. And negative 2 plus 4, which is positive 2. And that is our final answer. Nothing else can be simplified. Now let us have a look at what happens when polynomials are being divided. Now, just bear in mind, they tell us here that x cannot be 0. And let us just explore what happens if x is 0. Well, in the denominator, I have 3 multiplied by x. And 3, what happens if x is 0? Well, 3 times 0 is 0. And we all know that mathematics just breaks when we divide by 0. And so x just is not able to be 0 to start with. Now, when I have a polynomial like this, when I have multiple terms in the numerator, I can split this entire fraction up into a few smaller ones. So I can say 9x to the power of 4 all over 3 to the power of x. And then I go on to this next term. And so negative 6x to the power of 3 over 3x. And we go on, 3x squared over 3x. And our last one, plus 12x over 3x. Can you see I have been using these signs as the divider for my terms when I have split up our fraction? And so now I can deal with each fraction on their own because I have one term in the numerator and one term in the denominator, so I can do my exponent work. Please be remembering that you cannot apply your exponent laws when there are multiple terms in the numerator. We first need to split them up. And so let us have a look. 9 goes into 3, a total of 3 times. And x to the power of 4 over x to the power of, mind yourself, of 1. And so the exponents subtract, which leaves us with x to the power of 3 all over 1. But anything divided by 1 remains the same. So let's continue. 6 over 3 is 2. X to the power of 3 over x to the power of 1 is x to the power of 2. And let's go on to the third term. 3 over 3 and x squared over x, which leaves me a variable of x. X to the power of 1. And lastly, let's go 12 goes into 3, a total of, this is positive, 4 times, and x goes divided by x, those two cancel out. And so let me see, can I add or subtract any like terms?
No, there are no like terms, so I leave my answer simplified like that. All right, now it's your turn. Go ahead, give it a try. But always remember, do your best and pray for the rest.